This conference will now be recorded.
So very good evening, students. Today we'll start discussing numerical problems from a new chapter, that is system of particles and center of rotational motion. So there are various things in that: moment of inertia, center of mass, etc. So to know or to discuss the motion of a rigid body or a system of particles, we first need to define center of mass, because laws of motions are applicable only for the point masses, and when we have extended object, for them also we will be applying the laws of motion given by Newton, and that can be done only when we define a center of mass, where center of mass means a point where the whole mass of the object is concentrated. So that will act as point mass, and then we can discuss the motion of the center of mass such that we can get the nature of the motion or the details of the motion of the whole object itself. Okay, all right. So this is the significance of discussing or uh, defining center of mass for a system of particles or rigid body. Okay, so let's discuss this problem. So the first problem from this chapter, this is actually the question asked in 2015 JEE mains exam, JEE main 2015. The question is that the distance of the center of mass of a solid uniform cone from its vertex is z0 if the radius of the base is capital R and its height is small h, then z0 equal to what? I'll tell you what it is. Suppose this is a solid uniform cone and its vertex is this one, so this is called vertex. So if we draw a line from here, like through the vertex, the center of mass of the cone is situated somewhere here, z0 distance from this vertex. Okay, this is vertex, this is O. So this, suppose this is P, so OP, this, suppose this is the point where the center of mass is situated, P. OP is Z0, that is what is given here. What else is given? The radius of this base of the cone is given as capital R. Then you have to find out what is this Z0 or OP distance is from the yes, what is this Z0 is. So to solve this problem, actually we have to one more information is given, that the height of the cone is h, small h, that is what is given. So to solve this problem, actually you have to find out what is the center of mass, like what is the position of the position coordinate of the center of mass. Okay, if we consider this in 3 dimension. If I consider this as 3 dimension, this P point has 3 coordinates, X, Y, and Z. Okay. So this is the, suppose this is the position coordinate of the center of mass. Now, how do we find out X, Y, and Z? We know from the definition, XCOM will be XDM, right? Over 1 by M. If I say XCOM, this coordinate XCOM, YCOM, and ZCOM. Similarly, we can find out YCOM, center of mass coordinate, 1 over M, YDM. Like that, we can do. Now the question is, what is DM? What is this DM? How to find out this DM? So if you know the result where the center of mass is situated, that is different. You can do it easily. But what I'll do, I'll just teach you how to solve or how to calculate center of mass coordinate for this solid cone first. Then you'll be able to solve this problem easily. Okay. So for that, let us consider the density of the material of this is rho. Suppose density is rho. Density is rho. And we are just considering, if you can see, we can just think of an elementary thick disk. Okay. At x distance, suppose okay, this is, suppose, let me, for the time being, let me just take this as x distance. Okay, not x, let me say this is y distance. Y distance. Okay. I'm sorry, I'm just considering the distance y from the down. Okay, let me check with this. So let me say this is y distance, so this will be h minus y. This is the distance, which is z0 actually. Okay, so let me think a circular disk, thick disk actually, which has a radius x, small x, radius small x, and it has thickness this much. This thickness is dy. Okay, I'm just writing it clearly. So this thickness of the disk is dy. At y distance away from this center of this base of the cone, I have considered a thick disk. Okay, thick disk, and that disk has radius small x, small x. Okay, now I have to find out what is the mass of this elementary disk. Before we do that, let me apply the rules of similar triangle so that I can get a relation between x and this capital R. Okay, rather, and again the relation between y and h minus y, etc. So if we consider similar triangles, similar triangles, so suppose this is one, this O, this is P, and let us say this is something like A, OAC, sorry, OAP, one triangle, and another triangle, suppose this B, and this is Q. Similar triangles OBQ and OAP. These two triangles are there. Now if I just compare, what I can write is the whole heights are actually the ratio of heights, and we can write like this. Okay, so from here you look, we can get x is equal to h minus y into r divided by h. This is what we get, a relation between h, y and r with x. Okay, so I have got the radius of this disk. So mass of the disk will be what? Mass of the disk, suppose mass of the disk is m disk. So the small m mass, see I know the disk density is rho, so pi x square into dy, this is the volume, into rho. This will give you the mass of this thin disk. Okay, so let us just put the value of x. Pi x square means, see, r square h minus y whole square divided by h square. Okay, and along with that rho will be multiplied. Okay, so pi rho h square whole into h minus y whole square divided by h square, and obviously there was dy here, dy also will be there. Okay, this is separate thing. Okay, so from here look, I would not say m disk, let me say delta m, because I have taken a thin element, a thick like small element of the disk, like of the cone as disk, and that disk, if I just continue to grow the radius and all the way from 0 to capital R, then I would actually get a cone like this. Suppose I have this disk, then like this, then bigger than this, and look, this will give you a cone structure, right? So if I just combine all such disks together, I'll get a cone. Okay, so I have got the mass of the elementary disk over here. Okay, now dm I have got. So if I want to calculate what is the x coordinate of the center of mass, then we can write xcm is equal to 1 over m x dm. So look here, 1 over m x, let me write x, pi rho r square h minus y by h square into dy. Okay, so you look here, here you you can just see, if I think that this is the x axis, this is as y axis, the center of mass is actually, center of mass will be along this line itself. Okay, on this line, anywhere on this line, this vertical line, or on the y axis. So if this is origin, q is origin, then center of mass coordinate, actually x is actually here 0, you can see that x is 0 here. Okay, x is 0, that means the center of mass is actually on the y axis, not on the x axis. If this q point is origin and this is x axis, this is y axis, so it is actually situated. And on the other hand, yes, so this is the reason that the center of mass coordinate x coordinate will be 0 because the center of mass is situated on the y-axis, not on any other point. Okay, this is on the vertical axis. By symmetry, actually, you can understand this center of mass coordinate actually lies on the vertical axis or y-axis. So that's why similarly ZCM also will be 0. So only there will be y coordinate. Let us now see what is the y coordinate of the center of mass. So that would give you the position of the center of mass. So we have got x is equal to 0, y is equal to 0. Center of mass coordinate x and y are 0. Sorry, x and z are 0. xm 0, zcm 0, because the center of mass is situated on the vertical axis over here, which is y-axis. So now we can find out ycm is equal to 1 over m y dm. So 1 over m y is there, and there are few constants, so pi r square rho divided by h square, and this is here h minus y whole square dy, and this y is also there. Now what we have to do, we can just take this pi r square rho by h square out of the integration, then we get y h square minus y square, sorry, plus y square minus 2hy, this one, and dy. Now if we integrate it, see what we get, and obviously the limits will be 0 to h because the vertical height is small h, so 0 to small h. If we do the integration now, okay, let me go to some blank page. I have integration ycm to do is pi r square rho by h square. I hope these are the points. Yes, pi r square rho by m h square. Even m also will be there here. And see here y h square plus y square minus 2hy into dy. Okay, now then this factor, let it be there, pi r square rho by m h square. So this is y square along with this. So y square, this is 0 to h. Y square by 2, that means h to the power 4 by 2. This is cube, so 1 over 4 y to the power 4 minus, this is square, h in y into this square, so h by h to the power 4 2 by 3, 2 by 3 actually. Two by 3. If you just do this integration with proper limit, then what we get, this is also h to the power 4. So h to the power 4, let it be here. So 1 plus 1/4 minus 2 by 3. So LCM, if you do, this is actually 12. This 6, 3, and again 6. Sorry, 8. 8, so this will be 1 over 12. Okay, 1 over 12. So if this is the case, so here we are getting pi r square rho h to the power 4 sorry, h cube, suppose h cube 12, not h cube, this will be h square, because down it is square, this is h to the power 4, so 12. That will be m, obviously. Now look for a cone, the mass actually will be 1/3 pi r square rho. This is the pi r square h, pi r square h. This is pi r square h. This is the volume into rho. This is the mass. So if we substitute with 1/3, so this will be actually into 12. So 1/3 will go, means, let me write, pi r square h rho by 3, and here we'll get h by h over 4m. Okay, so this is also the mass of the whole cone, and this is also mass of the whole cone, so they will actually cancel each other, so we'll get h by 4. So y coordinate will be, so what is the center of mass coordinate for a cone then? X coordinate is 0, y coordinate is h by 4, and z coordinate is also 0 by symmetry. Okay, so these are the thing we have got. Now let me tell you this. From here it is z0 given, suppose this is the center of mass, suppose z0 is given, and from this point, this we have got y. So what is y? We have got y is equal to h by 4, and this height is given h. So this z0 will be actually, z0 will be h minus y. H minus y means h minus h by 4. So this will give you 4h minus h, that means 3h by 4. 3h by 4. So z0 is 3h by 4. The answer is 3h by 4 is this A. See, I have this elaborately done this problem near you because I just wanted to tell you how to calculate the center of mass for this particular geometry, a solid cone. That's why I had elaborately derived everything. But if you know that this this YCM is center of mass coordinate is h by 4, h by 4. If someone knows this, then they can directly go h minus h by 4. Okay. So sometime it is helpful to remember some informations. Like in this case, if someone knows that the y coordinate is h by 4, and this is z0 is y, h minus y, then they will be able to find the answer, okay, easily. Now we'll move on to the next problem. This is also a very interesting problem. A particle moves in xy plane under influence of a force such that its linear momentum p is actually varying with time like this. I'll write what is the linear momentum clearly. The linear momentum is a into I cap cos of kt minus j cap sine of kt. So this is actually the linear momentum, and this is how it varies with time. Now the question is the angle between the force and the momentum, linear momentum. The angle between the force and linear momentum will be what? So what is the definition of the force and linear momentum? Like what is the force, how the force related to linear momentum? that is dp by dt, or time rate of change of linear momentum, is force. Time rate of change of linear momentum is called force. Now if we just calculate what is force over here, we'll just get a I cap will be as it is, cos will be minus sign here, minus sign, okay, along with k multiplied over here. Similarly this will be minus j, k will be there, then this will be cos of k omega t, and a is common for both, so you can write, if I just take the minus sign common, then we'll get ak, let it be a separate constant, a prime maybe, so I cap sin omega kt plus k cap k cap cos kt, j cap cos kt. Now if we take, so this is the force, so this constant is anyway doesn't matter over here, it is the thing with the direction, so this will be, so if we find out the dot product f dot p is equal to, see, if we calculate the dot product of these two force, then we know how to calculate the angle between two vectors, right? We know the theta will be actually tan inverse a dot b divided by a b. Okay, so this is the angle, we can find it out, and we can, what we can do is we can just take the dot product. Dot product means if, okay, let us just first do it here. See, f dot p, f is here I dot, so that is fine, ak cos k kt sin kt, okay. Then similarly, if we multiply j with this, because ij will be, so this will actually cancel each other, and see, from the j to this will give you, this is minus sign, this is, there is a minus over here, so this will be minus, this is minus, so minus minus plus, basically this is minus, okay, let me just write it down. If you take the dot product, then you get a k this sine cos, so you'll get this cos of kt into sine of kt with a minus sign over here, okay, let, this is k, and this, see, this one will be giving you non-zero value over here, and there is a minus sign over here and here, so this will give you positive sign, so cos kt, and this is sine kt, okay, these are actually same, but there is a negative sign over here, so this will give you 0 ultimately. So basically what you are doing, you are just calculating the force, equation of the force or the expression for the force just by taking time derivative of the linear momentum, and then you are multiplying both F and P, like not multiplying, you are taking dot product so that you can calculate the angle. I'm sorry, not that was not so F dot P, they will give you actually cos of theta, not tan theta, I'm sorry, cos theta into this F and P like this. We have learned already in the vector part. So theta will be cos inverse of that. Okay, cos inverse of F dot P divided by F P. Okay, look then, if I get theta is equal to 0, theta is equal to 0, sorry, not theta is equal to 0. If I know the dot product is 0, then theta is equal to cos inverse 0, 0 degree. So cos inverse of cos 90 I can write, and from here I can write that theta is equal to 90 degree. So this is the answer. Okay, so dot product, take dot product and then write cos inverse of that result so that you get theta. Okay, so this is second question, and then let us now take up few more questions. I'll just take up one more problem. This is not a numerical problem but thoughtful question. Let me just write it down. If the resultant external force, if the, I'm sorry, if the resultant of all the forces, forces in the sense external forces here, external forces, all the external forces acting on a system of particle, acting on a system of particle, system of particles, system of particles is 0, then from an initial frame, from an initial frame, sorry, inertial frame, from an inertial frame, from an inertial frame, one can surely say that there are four options. First one is linear momentum of the system doesn't change. I'm writing in short, linear momentum that is P of the system does not change. Okay, then second is kinetic energy of the system is constant. Then option C, angular constant in the sense doesn't change. Angular momentum of the system does not change. Angular momentum L, which is R cross P. Angular momentum of the system does not change. Does not change. And this fourth option is potential energy. Rather, I will write in short note so that we can cover it. Abbreviated form. Potential energy. Potential energy of the system of particles. So potential energy of the system of particles does not change in time. Change with time. Okay, so you have to answer for this question. The question is, if the all the external forces acting on a system particle is zero, then what happens? Whether linear momentum conserved, angular momentum conserved, kinetic energy conserved, or potential energy conserved. Okay, let me analyze this. See, linear momentum is given by dpd. Linear momentum is all right. R cross. Linear momentum actually is related to force. If I write the external force is exactly equal to this. So if this is okay, if this force is zero, look, if this force is zero, external force, then this must be zero. If this is zero, then P is going to be constant. Constant in linear momentum conserved. If all the external forces are zero, okay, on the particle. So this is how we can arrive to this conclusion that the linear momentum of the system of particle does not change. That we can say. Otherwise, we cannot comment anything on these three, because uh, from inertial frame we can just guess this one, okay, or maybe we can see that linear momentum doesn't change, but other parts or other things like kinetic energy, then angular momentum, potential energy, they may change. So that's why linear momentum is the best option or the correct option here. Okay. Now we'll take up one more problem. Suppose a particle moves actually particle has mass m. Suppose a particle of mass m moves in xy direction, xy plane, okay, in the x direction, say, with a speed with 2v. is hit by another particle of mass 2m moving in the y direction. Y direction with speed, suppose with speed v, if the collision is perfectly elastic, then the percentage loss of the kinetic energy during this collision is close to what? Okay, so the question is, if the collision is perfectly elastic, this is inelastic, perfectly inelastic, then the percentage change percentage change in a percentage loss, not change, percentage loss in the during the collision is close to, the options are actually 50 percentage, option B is 56 percentage, option C is 62%, now D is 44 percentage. I'll just make you clear once again. So a particle was there, suppose of mass m, which is moving in the x direction with a velocity 2v or speed 2v, hit by another particle of mass 2m moving in y direction with speed v. If there is a collision between them and that collision is inelastic, perfectly inelastic collision, then what is the percentage loss in the energy during the collision? That we have to calculate. Let me just draw the schematic of this actually. So the situation is this, that this is x direction and there was a particle which is moving with 2v speed. Another particle was there which is moving with velocity, so this is 2m having velocity this or speed v. They collide with each other and this is in perfectly inelastic collision. Then what will be the percentage loss of the energy? That is what we have to find out. So in this case, like inelastic collision is actually defined as like when, see, inelastic collision means any kinetic energy not conserved. not conserved. Potential energy not conserved. Okay, but total energy will be conserved, that we can use if we know. Another point is that the linear momentum is actually always conserved. Linear momentum is conserved for any type of collision. Any type of collision. Okay, any type of collision. So what we can do, we can actually write down the conservation of linear momentum here and find out the final velocity. Okay, we know the initial loss in, I think this energy loss in kinetic energy only you have to find out. Okay, loss in kinetic energy only we have to find out. So first, see, initially they will actually collide with each other, since it is inelastic, so they will actually stick to each other. They will stick to each other and they will move then. Okay, so we have momentum conservation. See, m 2v into m, this is along x axis, plus initially 2m v along j is equal to final one, suppose they combine together, that is m plus 2m, that means 3m into, suppose some velocity v collision, after collision. Okay, this is a vector quantity. Now to find out the magnitude of this, look, vc will be then 2vm by 3m plus 2mv again by 3m. Okay, this is I cap, this is j cap. Now what will be the magnitude of this? Magnitude will be, see, mm goes off, so component of this 2v by 3 or 2 by 3 v square, v whole square, here also 2v by 3 this, so 2 root 2 by 3 into v. This will be actually the speed, final speed. This is the magnitude of the final speed. Now initially, what were the energy? Initial kinetic energy, kinetic energy, half m 2v square, half mv square. Okay, plus half 2m only v square. Okay, so this is the kinetic energy, initial kinetic energy, and if you look, this will actually give you 4 means 2m v square, here also 2m v square. So this is I'm sorry, this is 4, so 2 and here it is 3, sorry 1, so mv square. So this will give you actually 3mv square, 3mv square. And what is the final kinetic energy? Final kinetic energy, half cm vc square, vc square mod square or vc square, anyway, vc mod square. Okay, So 3 by 2 m v c square is 2 root 2 v by 3. 2 root 2, sorry, 2 root 2 by 3 square. Now then you will get 3 by 2 m 2, sorry, 4 into 2. So you will see, I'm sorry, that half 3m, okay, half 3m v c square. So this will give you 4 into this is 8 anyway. This is v, this is 9 v square, all right. Okay, let me just check what is there. Yes. So this is 2, 2 goes up and this is 3. So 4 by 3 mv square. 4 by 3 mv square, and earlier what was there? 3 mv square. So 4 by 3, 9 minus 4, that means 5 by 3. So loss in kinetic energy will be final minus initial. Final was 4 by 3 and initial was 3m square. Actually, if I check the change or loss in kinetic energy, if we check the mod, you know what we get? 9. So 5 by 3. Okay, 5 by 3 mv square. Percentage change means loss divided by initial. So loss was 5 by 3 mv square and initial was there 3 mv square into 100. Okay, so mv square this goes. Okay, so if you, okay, let me just check it. 109. So sorry, this is 500. So this will be 45, then 5 again, 5, 45, 5. So it goes on like this. So it will be around 56%. And there were options. One among them 56%. Okay, not 50, not 44, not even 62. It is actually around 56%. So this is how you have to actually. So there are very many concepts like center of mass and its motion, linear momentum, angular momentum. Since it is like we are going to deal with rotational motion, so there are various things like that. So center of mass coordinate, then how to calculate center of mass coordinate, then how to apply various conservation law, moment calculation, moment of inertia, etc. Will be coming in this chapter again and again, and we'll be actually solving very nicely many other questions in the next classes. So we'll stop it here for today. Next class we'll take up more problems from various other uh, previous year's paper. Okay, so bye for today. Thank you for your patience.